In the Module 5 Lesson 9 problem set, we're going to look at reducing fractions similar to how we multiplied. So what we said in multiplying fractions is if we reduce or if we increase the numerator and the denominator by the same amount, that those fractions have the same values. So for instance, if I have the fraction 1/2 and I want to increase by 2 times, if I multiply the 1 of 1/2, that would be 2. If I take the 2 from 1/2 and multiply that by 2, it would be 4. So 1/2 equals 2/4. The same thing can happen with division. So it reads, every rectangle represents 1. Compose a shaded fraction into larger fraction units. Express your equivalent fractions in a number sentence using division. The first one is done for you. So as we can see 1, 2, 3, 4 pieces, and 2 of them are shaded, so 2/4. But I can also find that I can reduce 2 and 4 both by 2. And I have to be able to do it for the numerator and the denominator. So dividing 2 by 2 is 1, and dividing 4 by 2 is 2, telling me that 1/2 of our rectangle is shaded. And here we have 1, 2, 3, 4, 5, 6. So we have 3, 6 shaded, and I can actually recognize that there's a common factor of 3. So if I divide 3 by 3, but I also have to divide 6 by 3, I can find out that 3 divided by 3 is 1, and 6 divided by 3 is 2, which again represents 1 out of 2, or 1/2. Jumping down here, let's look at this. 1, 2, 3, 4, 5, 6, 7, 8. In this case, we're going to have 4 out of 8, which equals 4 and 8. What could I divide both? I could divide by 2, but I could also divide by 4. That would be the best one to divide by. And 4 divided by 4 is going to equal 1. 8 divided by 4 is 2, which gives us 1/2. Moving over here. Compose the shaded fractions into larger fractional units. Express the equivalent fractions in a number sentence using division. Okay, so if we were to look at this, so we got 1, 2, 3, 4, 5, 6. So this would represent 2 out of 6. What could I divide both 2 and 6 by? Well, the only other factor for 2 is 2. So 6, can that be divided by 2? You betcha. 2 divided by 2 is 1. 6 divided by 2 is 3. So when we look at this in the column sense, 1/3, 2/3, 3/3, the shaded amount would be 1/3. In a problem like this, we would have 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 12s. If I divided both 2 and 12 by 2, it would be 1/6, and that's what this would represent when looking in columns. So what happened to the size of the fractional units when you compose the fractions? What we're noticing is as we continue to increase, the items get smaller, but actually this would be 1/3, a little hint and preview. This will be 1/4, you'll see 4 columns, 1/5, 1/6. The numerator stays the same, 1, but the denominator increases. But interestingly enough, I want to point this out, as the denominator increases, the sizes of the squares get smaller. That's a key point, right? Total number of units as a whole, when you compose the fraction, they would increase. All right, looking over here. In the first area model, show 2/6. In the second area model, show 3/9. Show how both fractions can be renamed as the same unit fraction. So we're going to separate this into 2/6. 1, 2. And this one we're going to do 3/9. 1, 2, 3. And mainly when we look at this from this end, we can recognize that they both can be renamed as the same unit fraction. In this case, 2/6 could be divided by 2 and this divided by 2 to equal 1/3. In this one, 3/9 could be divided by 3 and divided by 3, which would equal 1/3. third as well. The same value, I just chose to break it into smaller but more pieces in this one. And in this last problem, you'll break it into 2/8 and 3/12 to show how they would be renamed. This is one you can try on your own. The key here is, in an example of 2/8, right, and 3/12, what can I reduce both by? Okay. What can I reduce this by? And then we're going to see what that comes out to see if it's representative in both our area model and our reduction of the fraction. We call a lot of this times, we'll call this simplification of fractions, or in its lowest terms.